So welcome everyone to our last but not least webinar for today as a part of the AgentCraft hackathon, where we're gonna host two experts from the industry. The first is going to be Vitalii Duk, the CEO of Dynamiq, and he is going to give us a 30-minute talk about intro to multi-agent applications. So thanks for coming, Vitaly, and the stage is yours.
Thank you. Thanks, Nir. Thanks for having me. Pleasure to present it to the audience. So yeah, as Nir said, I'm Vitalii. I'm the founder and CEO at Dynamiq. I've spent past 12 years in the data science space, did a lot of classic machine learning. These days, I'm building Dynamiq. We're kind of all-in-one platform that helps enterprises to build agentic workflows, agentic applications. We also have our open source package that also I want to present today that helps users build the agentic applications. Here's my LinkedIn as well for anyone who wants to connect and chat after this. But I highly recommend check out our open source repo on GitHub to kind of see what we've built regarding agentic orchestration. And then today I'll show a couple of examples in how you can build some of the applications using Dynamiq as well. So yeah, let's get started. First, I wanted to chat and kind of give the intro about what are the LLM agents, because a lot of people kind of overwhelmed with all the information that's going on. So I wanted to distill what actually is the LLM agent. And there's nothing fancy, there's nothing sophisticated. LLM agents are kind of another evolution on top of LLMs that help you perform more complex tasks. And if you think about it, it kind of breaks down into a couple of things that we do with LLMs. We wrap certain functionality over the LLMs and allow it to first reason regarding the input task, then plan the actions, and then kind of execute the tasks in some shape or form. So the LLM agents are essentially built to perform something more complex than just simple text generation and question answering. There are a couple of components that are crucial to build LLM agents. One of the core thing where the whole journey starts basically is the planning. Because when the agent receives the incoming task or a query, it needs to kind of decide what needs to be done to solve this. And there are a couple of various techniques or architectures that are typically employed to do this. Some of the common ones might be reflection or React agents that we'll deep dive into later. Then these agents, they also have access to the tools that they can execute. And essentially what's happening is that these tools are included in the prompt that is used for reflection or chain of thoughts. So the agent knows what capabilities it has, what can be executed, what actions can be performed. The third component is the memory. So short-term, long-term memory that allows you to store some of the previous information about the current session or the current user that interacts with this agent. Again, we can go into details how the memory can be implemented. And then the fourth component is that the agent can actually execute some of these tools, perform some of the actions, get the output, analyze it, and then kind of probably perform another cycle of reflection or another chain of thoughts interaction that will determine the next action. So at its core, agents probably have been around for decades, if not more. But what's changed is that the planning and actioning capabilities are now being replaced by LLMs that replace probably some of the old school hard-coded logic that was used in the previous generation of agents. I think one of the closest things that I typically use as an analogy to an agent is probably like an actor model, and the frameworks like Akka in Java, they kind of been operating in the similar kind of concepts before, but now I think we have LLMs that are more sophisticated and more capable. The tools are also probably one of the crucial components of the agents. So these are the things that allow agents to interact with the outside world. So call external APIs, scrape the internet or search the internet, perform things like text to speech, speech to text, interact with any other platforms like your calendar, your inbox, maybe your Jira or other tools that you have in your arsenal, and then perform some of the tasks. I mentioned the memory, and there's essentially nothing very sophisticated regarding the memory. The main responsibility of the memory component is to be a storage of all of the interactions. And there might be very simple, let's say, short-term memory implementations that just store the current user session messages and uses that in the context, essentially adding these messages to the prompt that is used for planning or reasoning. And there might be more long-term memory where we potentially store all of the interactions that happened with this particular user in the past, and we can selectively retrieve based on the similarities or like vector search the historical data that is relevant to the current interaction. So this is something that can leverage vector databases to store all of the interactions, and then vector search to perform the retrieval of the most relevant topics and not the entire history of conversations of this user. The planning module, planning capability of agents, again, it's done by using LLMs, and the LLMs are playing the crucial role here. There are two types of frameworks that are currently employed for planning. There's planning without the feedback, where we basically task the LLM to take this incoming request, incoming query, and then break it down into actions that needs to be performed, taking into account the historical conversations, taking into account the tools that are available. And there is also planning with feedback, which allows the agent basically to leverage human in the loop to approve or disapprove, edit the list of tasks that it decided to perform. So this might be used in some critical scenarios where the mistake is not possible, and we want to validate whatever the LLM has planned before executing it. In our implementation of LLM agents, and I've seen it in other libraries as well, there are kind of ways that you can infer what actions and what tools can be called. One of the probably the simplest ways, and where everyone started, was by parsing, by tasking the LLM to actually plan the actions and then parse the output of the LLM using regular expressions and determine, based on the regular expressions, which actions should be performed. It's very fragile, kind of very much depends on the temperature of the LLM that you set, very much depends on the size of the model that you're using. So this is something that kind of goes away these days, and What we're focusing on, and a lot of folks are focusing on, is leveraging either structured output of LLMs like OpenAI structured output or function calling to actually do planning and do the tool selection and the actioning as the core thing that the agents perform. Again, this is still something that not every LLM supports. So structured output is very limited to just a few LLMs. Function calling is more widespread, but still not every LLM has that. So we in Dynamiq, what we've done, we've kind of implemented different strategies and different inference modes that you can switch depending on the LLM that you use. When it comes to variety of approaches to build LLM agents, there are a couple of things that are cutting edge these days or have been researched for a while. So there's obviously a very simple agent that just has the set of tools, gets the incoming query, and then tries to in a single shot basically define what needs to be performed, what needs to be actioned. There is a React agent, which is more a loop that consists of the reasoning step and then the actioning step, and then it can iteratively improve. So you can set the number of loops for the React agent and execute it in a kind of sequential manner. There's also reflection agent that is kind of very similar to the React agent, but just applies a different strategy of prompting. So first it generates reflections and then kind of performs the actioning, similar to what OpenAI's O1 model does before generating the output. It's actually a very good example of kind of more or less reflection strategy. When it comes to the way what we at Dynamiq have designed the agents and the way you can use them. So when we take a simple React agent in Dynamiq, there's a way to set the LLM that powers it. There's a way to set the set of tools that we also pre-built. We have the way to abstract it. As I mentioned, you set the inference mode that you want to use for this particular LLM agent, and then you define a role, like what this agent will perform. Like, is it the research agent? Is it the code writer? Is it the customer support agent? So it's pretty lean. Like there's not a lot to configure. And then basically when you define this agent, you can just invoke execute method and pass the incoming task as a simple string, and then it's gonna do all the magic behind the scenes. When it comes to like the full-fledged example, I'm here. I just wanted to show like how the end-to-end example of building the agents in Dynamiq works. As I said, we have a bunch of integrations with all of the LLMs available on the market that you can define. You can define these tools. Again, we've built a lot of tools already that you need to care about, like web search or interpreter tools. And then what we also have as part of the library is the ability to define workflows. So you can stack together these agents in any way you want. So essentially the workflow is a DAG that allows you to build very sophisticated and complex workflows. And then you can just invoke the entire workflow with a simple run method and pass the incoming task. And in this case, I'm showing like how we can build the code assistant that help us code essentially. Again, here we're using the simple React, so reasoning actioning agent. Just to summarize again, like how exactly what's happening in the previous example, right? So when we submit the incoming request, it's going to be an LLM call as part of this React agent that will try to analyze the incoming task and then basically plan what actions should be taken. The tools that we've defined will be added as part of the prompt for the planning, and then the output will be just a set of actions to perform. And then the agent will try to execute every action sequentially. So let's say if in this example we have the search tool and the code interpreter, most probably based on this input, it's going to first trigger the search. So we'll try the research the web, scrape some of the results, based on the output, analyze if it has enough information, perform another kind of planning, and then execute the interpreter, generate the code, and then execute the interpreter, understand if it's executing well or not, and then if the code that it was generated actually works, then it can finish the execution essentially. There is another more sophisticated thing that obviously the point of today's presentation is about is the multi-agent orchestration. Single agents are great, but what we all know is kind of including a lot of things, a lot of capabilities into a prompt and telling that this agent can do, a code generation and writing and all the tasks. It doesn't really work because then it just kind of performs poorly on the task. That's why the kind of new approach is to orchestrate multiple agents that are specialized in certain areas. So more like stuff that you do in the real world teams, right? You have the specialists in certain areas that are good at specific tasks, and then there's some sort of manager in that team that manages it. So there's several kind of strategies that are being developed these days. And the way we approach the multi-agent orchestration in Dynamiq, we have the supervisory based orchestration, where there is a manager agent that is responsible for two things. So it's responsible for planning, and then it's also responsible for assigning roles and assigning specific tasks to specific agents. I'll show in a minute how it's done, but that's probably one of the most efficient ways these days. There's also hierarchical orchestration that allows you to create multiple supervisory levels. So you can have teams and sub-teams. It's a bit more challenging, but again, it's designed to solve more complex tasks that the real humans actually are capable of doing. And then there's actually a variety of custom orchestration strategies that you can allow you to define your own ways of how agents collaborate. And I think one of the probably good examples here is the LangGraph that actually allows you to define the way agents actually should communicate with each other, like what are the possible transitions and stuff like that. But it allows you actually to define these relationships and transitions and communication between different agents. I think the kind of one of the benefits and also kind of drawbacks of the multi-agent orchestration was the manager agent is that at every step there is a manager that decides what needs to be done, but you don't really set the specific transitions that should happen. So it's up to the LLM at its core to define what actions should be taken, which agent should be called now. Is the output correct or not? Should we continue or not? Again, this at this stage is probably a bit more prone to errors because there's no way to kind of constrain in this scenario the possible transitions. But I would believe that this is the ultimate goal where we're going. So we would not need to build like custom orchestrations and things like that if we have powerful enough LLMs to actually run the orchestration. Again, when it comes to the multi-agent workflows in Dynamiq, it's pretty straightforward. We can, as I showed before, define a couple of agents, give them roles, define which LLM is again powering them. And then we have the several strategies as well, like whether adaptive or linear orchestrator that actually can perform the multi-agent orchestration. So in the same way, we can add it to the workflow and then execute it. So what's going to happen in this adaptive orchestrator, we've defined the manager, which again is powered by the LLM. It has its own kind of prompt that takes care of planning and assigning roles. The manager will receive the initial input from the user and then will define which actions should be executed by which agents. And then it will start executing. And then the kind of beauty of the adaptive orchestrator is that after each execution, the manager kind of decides whether we should continue according to the initial plan or should change something in the initial plan, should replan something, or did we finish the execution? Did we reach the final output? So it's also the reason why it's called adaptive, because it can adapt. So if something is not going according to plan, then it can change the original plan as well. The linear orchestrator that is also available as part of Dynamiq allows you to actually just always stick to the plan. So the manager will only once determine the plan and then assign the roles and then start executing without kind of ever replanning the original plan. When it comes to the places where LLM agents can be used, there's actually a ton of things. We've been working with a lot of enterprises these days. One of the biggest kind of spaces here is the customer support. We currently work with several banks where we're helping them build LLM agents to automate the customer support. It's super effective. Companies see 50-ish% reduction in the amount of customer support tickets that are processed by humans. So LLM agents are proven to be very powerful in this kind of scenario. So other places, another category that we see is emerging is all types of workflow automation, back office automation. And essentially, just yesterday, I saw the article from Andreessen Horowitz where they say that the LLM agents going to disrupt all the companies similar to UiPath and Zapier and so on and so forth, because the LLM agent is going to be more powerful and capable of solving some of the more challenging tasks without the need to define the steps of each workflow. So the beauty of LLM agents is that you can give it a complex task and it can do the planning and select the appropriate tools and execute them, understand if the results are correct without the need to kind of define the steps that needs to be taken. So from my side, it's pretty much it. As I said, I encourage everyone to check out our library. We have plenty of examples under our GitHub repo that are also covering multi-agent orchestration. There's a couple of blog posts that we wrote on how to build things like, complex customer support systems using multi-agent orchestration, how to build, autonomous data analysts using multi-agent orchestration. So really encourage you to check it out. And then again, here's my LinkedIn. Feel free to connect and we can chat more on that topic. So that's it from my side. Thanks a lot. Thanks, Nir. I hope that was really helpful. And if there are any questions, feel free to shoot them over.
Yeah, so there is a question from the crowd from Estefania. She is asking, actually, she's asking what is the difference between actions and tools?
So the actions pretty much the tool is something that you kind of define and it's kind of static, right? The action is the execution of that tool. So essentially, it's the same thing. It's just different kind of wording. So when you define a tool, the agent can actually perform the execute that tool a couple of times. So the action is just like one execution of the tool. So it's just the terminology thing, but no major difference in it. It's just, yeah.
Mm-hmm. Thanks for the clarification. And well, thank you very much. Obviously, all the links that you shared here, I'm going to attach to the YouTube, so they're going to be clickable and people can get to either the GitHub or the blog and also your LinkedIn account. And oh, I see another question here. Can you expand on the different methods on maintaining long-term memory of the LLM?
Yeah, I mean, look, the stuff that we've implemented, if you go ahead and check the way long-term memory is implemented in Dynamiq, essentially using vector database as the storage, and then it performs similarity search. So extracting relevant memories from that vector database based on the incoming query. There are many other ways to represent this. Like we're working also on something a bit more sophisticated where you use graph databases to not just extract the relevant memories, but also kind of things that are related to this thing. So graph databases are good at kind of extracting more complex structures. But at its core, the storage layer can be either a vector database, a graph database, or just a classic relational database or Redis that stores some memories, and then you use some sort of filtering or vector similarity search to extract relevant things. So yeah, that's kind of in a nutshell how does the long-term memory works.
Mm-hmm. Great. So I think we're right on time,
Perfect.
and it was perfect. Thank you very much for joining us. And
Thanks, Amir. Was great chatting, and then we'll see you soon.
yeah, see you soon.
Bye.
And now we have our last speaker for today, but definitely not the least, Atai from CopilotKit, who is going to give us a talk about how to build agent-native applications with LangGraph and CoAgents.
Hey,
Hi,
Nir.
Atai.
Great to see you. And
Yeah,
Vitaly, I don't know if you're still here, but really enjoyed the talk.
I think he's left.
All right. Um, yeah, so yeah, great to be here. Should I just get started?
Yeah, sure.
Yeah, all right. How's the hackathon going?
So the hackathon just begun about 3 hours ago, and I already see a chatter in the Discord community, people asking questions, and it's just the beginning. So hope to see the advancements on the way.
That's great. Yeah, looking forward to see what people build.
Yeah.
Yeah, so I'm going to be talking today about building agent native applications with CoAgents, our CopilotKit's new CoAgents extension and LangGraph. Neil,
Wait,
can you?
Atai, I think you should need to share the screen.
You're not seeing it?
Uh,
It
yeah,
might be a
now
tab.
I see it. Now I see it. Yeah.
Okay. All right, great. Um, yeah, you can see it says build agent native applications.
Yeah.
Okay, great. Yeah, so again, speaking about building agent native applications with our new CoAgents extension and LangGraph. So just very briefly on CopilotKit. CopilotKit is infrastructure for building best-in-class AI copilots into any product. So copilots that you see the largest companies, the most kind of hardcore teams building, we make that possible for any team to really build into their product very quickly. We have drop-in solutions that are also endlessly customizable. So it can get running very quickly. And if you need to customize, you can do that. Open source, please go give us a star. Yeah, there's generally three parts of the CopilotKit ecosystem. There's Copilot UI with essentially React components, UI components for AI chat and other things like that. Support for voice, for suggestions, just kind of works nicely out of the box. We also support headless UI. So if people don't want to use that, they don't have to. We have Copilot OS, which is a system for surfacing the correct context, tools, skills, and subagents based on the user behavior. And the third part, which is what I'm here to speak about, is CoAgents, which is human agent collaboration infrastructure for building agent applications with LangGraph. So that's the overall. So just a quick agenda for what we're going to cover. First, I'll just very briefly speak about the agent native era and what has shifted specifically in the last few months. There's really things that you can build now relatively easily that are kind of breaking new ground. Then we'll actually do a deep dive, into CoAgents and very quickly go to a demo. So we'll actually be building a agent native application from scratch live. So fingers crossed that the demo gods are with us today. So first, just a few words on the agent native era that we've entered. Over the last few months, we've seen the emergence of a new type of agent native applications. Like if you guys are using the Replit AI agent or the new version of Vercel's v0.dev, to some extent also OpenAI's new Canvas, that are really kind of redefining what useful AI looks like. The top line, the common denominator between these categories is that agent native applications actually work, right? And they start to really deliver on the promise of AI, right? Which is usefully automating menial human labor. This is what's driving all of us into this ecosystem. What's driving all the investment, automating, kind of almost like a industrial revolution for knowledge work. And we're starting to see that actually playing out with these agent native applications. And these agent native applications work by combining two high-level themes. The first is really handcrafting of the agents, right? We're not just kind of YOLOing our prompts at an LLM and hoping for the best. Instead, you break down what happens in the application into substeps. And each substep is separately optimized with its own prompts, its own tools, its own code sometimes. And that's where frameworks like LangGraph really shine. So that's the first part of these agent applications. But the second part is a really tight human-in-the-loop agentic flows, right? So even after you've broken down your agent steps, you can get it to produce very cool results. But what pushes it from cool to actually useful and shipped is this tight human-in-the-loop flow, where the person works alongside the agent to produce the final result. A lot of people think of human in the loop as kind of just a confirmation dialogue, right? The AI goes and does something and comes back to the person and say, hey human, is this perfect? Thumbs up or thumbs down? And in reality, human in the loop that works is more like playing ping pong with the AI agent, right? The human does some of the work, prompts the AI agent. The AI agent does some of the work. The human might directly edit it or reprompt the agent. And through this process of back and forth communication, the end result is not just cool. It's not like, oh, look how close it is to what I would have made in many, many hours, but it's not quite shippable. But it's actually something that you can ship and get out there. And that's we've entered this age. This is no longer kind of futuristic. And so yeah, and this is essentially what CoAgents in LangGraph enables. It's everything you need to deeply integrate a LangGraph agent with an application to facilitate deep human-agent collaboration, right? That's where humans live, in applications. If you want them to collaborate with agents, you need to integrate these very tightly. And yeah, it's not just everything you need, but it's really everything you need to build best-in-class agent applications of the kind that, until a few months ago, only the most hardcore teams I mentioned, Replit, Vercel, I've managed to ship. If you've tried building something like that, I'm sure you run into the many issues of service, and now they become a few lines of code. So without further ado, I think we can skip some of the setup and just go straight to the demo and kind of take it from there. So let me share a different screen. All right, Nir, can you see now a web browser?
Yep.
All right, great. And so first of all, everything I'm going to show here is open source. You can if you go to our, sorry, actually not in our GitHub, in our documentation under CoAgents, the whole platform is open source, but so is this example. You can run it live here and also dig into the code that I'm going to show you. So let's go back to that agent. So this is Searchy. Searchy is the world's best research assistant, right? To help our end users conduct really great research on whatever topic they want. So let me just quickly show you how it works, and then we'll, again, build it essentially from scratch in real time. So I'm first going to write a research question here. So I can just control what this is for. I can add resources if I wanted to, right? URL, title, description. And I can also add a research draft. So let me pre-populate this with a format that I want, right? So I want to search the life cycle of penguins, but I know what type of results I want. I don't want it to be open-ended. I know what I want. So I want to have pre-hatching, and then youth period of the penguin's life, then adulthood, parenthood, and end of life. So now let's ask the agent to help me with this. So help me with this research. And one of the first things you'll see is there's now shared state between the application and the agent, which we communicate with through this open-ended chat interface. So everything that happens, these are no longer distinct systems, right? Everything that happens in the application, the agent is aware of, and vice versa. Another feature that you saw there before is Agentic generative UI, which is generative UI based on the agent state in addition to the tool calling abstraction. You can see what the agent is currently doing. You saw that as the agent was figuring out which resources to use, it filled it out and it got filled in the application in real time. And as the draft was getting written, that was also getting filled here in real time. And you see the draft follows the structure that I initially laid out because it saw what the state was to begin with. And we can now, this is, again, in the cool state. And if we want to get to the shippable state, we would iterate back and forth here. Another thing I want to quickly show is human in the loop. So let's say I want to say, these are too many resources. Let's get rid of the worst two. Okay. And it's going to suggest, hey, do you want to delete these resources? And, it's a dangerous operation. So it's asking me to confirm. So I'm going to say, yes, let's delete those. And now, regenerate it now, for example. And it's going to regenerate it based on these updated questions. So that's what we're going to be building here. You can kind of see in your mind's eye, hopefully, what these building blocks will enable to build in every domain outside of Searchy. And so our starting point is going to be, actually did not think through how to share the screen here, but let me figure this out in real time. But our starting point is just this, simple React application, no agent, right? We have, text field for answering questions. We can add resources. can write a draft. This is what an application would have looked like, 2 years ago, where the computer facilitates the work by a human, but that's where the buck stops. And so let me figure out how to share both. I'm just going to put it on this screen and hope for the best. 1 second. All right. Nir, can you see my screen over there
Yeah.
with code and with web browser?
Mm-hmm.
All right, fantastic. So yeah, this is the source code that I mentioned before. Again, it's open source. You can go and find it on our GitHub or through the documentation there. There's really two parts to this code. There's the agent code, and then there's the front end that lives in the UI folder. Both of these individually are pretty straightforward. So you saw the quote unquote dumb application. Let me now show you the LangGraph agent that we're going to be working with, and we'll dig into the details there in a minute. But just at a high level, it's pretty straightforward, right? We have our chat node. It can trigger searches. Searches can trigger resource downloads. We start with downloads because the user might have added a resource that we might need to download, that was not added by chat. And then we have delete and perform delete with human in the loop connection there, so the user can control that. So very straightforward agent, very straightforward application. And now we'll see that the glue between them has also become very straightforward. So yes, let's get started. The first thing we're going to do in the front end is wrap the relevant part of the application with a CopilotKit provider. You can have one of those across the entire application if you want. You can have many of those across different parts of the application. And this essentially binds everything that is contained within this provider to the Copilot runtime. Now, I won't get into all the things that this provides you, but what I want to notice here is this agent lock to the research agent that we define through LangGraph. So all the interactions with a Copilot in this case are agent locked to this agent. There's other modes of using CopilotKit. There's router mode, which can support multi-agents, can support other types of experiences as well. But now for simplicity, we're using agent lock. So that's actually all we needed to do to bind these two things together. These things are actually already bound together, but we can't see it yet. We need to add some UI here. And so we'll go to the main file, and we'll use Copilot Chat, which is one of the built-in components that ships as part of CopilotKit. Let me just uncomment this thing that is relevant here. But anyways, Copilot Chat is one of the built-in components. As I said, you can use one of the built-in components or just use your own UI from scratch using our headless UI solution. And these things can also complement one another. You don't have to choose necessarily. And as you see, these are also customizable components. So you can pass subcomponents complete from scratch, or you can just use CSS to customize. And actually, maybe let me show this really quickly. If you go to our documentation under customize look and feel, there's kind of a nice menu where you can hover over and shows you how to customize. But anyways, back to the application. So now actually we already can chat with this LangGraph agent, right? So I can say here, hi, and hopefully everything works, fingers crossed. All right. And the agent replied back. So that was neat, but let's keep going here, right? So the next few lines here, I'm just refreshing. That's why this went away. The next few lines here are pretty magical, so just pay attention so you don't miss it. I'm going to go to the research component, and I'm going to change. Let me make this a little bit bigger. I'm going to change the state from simple React state that we're all familiar with, use state, to state and set state that are provided by the useCoAgent hook. So now that's all it took, right? Before the state was local to the application. Now with just these two lines of code, the state is shared between the agent and the application. So everything that happens in one is reflected in the other and vice versa. So I can already now go back here and say, help me write a question about the life cycle of penguins, and I'll tell it, use your imagination, because I don't want it to start asking me all sorts of questions about this. And you see that it updated the state of the agent, and all of a sudden it's also updating the application. So that's really all it took to do this. And so now we can also ask that, okay, great, let's conduct this research. Now, those of you building with AI are very familiar probably with this loading indicator. Again, this is fine in demoware and applications that you show off on Twitter. You can speed up the GIF on Twitter and it's okay. But you can't really ship something that loads and loads and loads to users. We'll see here that in a moment, all the state will get updated and it will show up. So let's just wait for the resources to get figured out. Okay, now we have that. And soon we will also have the research draft going to get filled out here. I suppose it didn't do it in one go. So, okay, write the report too. But anyways, this is, again, we want to go beyond demoware to actually useful in production application to work alongside people. And so we're going to do a few things. First, we'll go into the agent code. And just to show you that this is really just plain LangGraph code, I'm not going to go too much in the details here. I know you had a session this morning with Lance at LangGraph. So hopefully this makes some sense, but generally it's very simple. LangGraph agent shows exactly what we saw in the visualization before. Now it does work as is, as you saw. This is plain LangGraph code, no changes whatsoever. But when we work with an agent, actually, let me do this slightly different order. I'm going to go here and add to the research canvas the Agentic generative UI that we saw before, right? So all it takes to do this is use this hook here, useCoAgent state render. We can choose which agent we want to render, and we pass in a really simple function that takes the agent state as input and returns any custom React component as output. Now, if we go back here, it should actually already show us that it's backfilled these into the application, right? So what happened previously as the agent was downloading resources is now actually rendering here as well. Now, the thing is, if you guys are familiar, and this is based on the agent state, which is the right abstraction for interfacing with the agent, because it's simple, it's deterministic, it kind of converges to the same thing. But if you're familiar with LangGraph, you know that the agent state only updates across node transitions. And these node transitions themselves can take, a little while, can take 10, 20, 30 seconds longer even. And so what we want to do with an agent that is designed to work alongside people is to also stream the intermediate agent state as it's getting figured out by the agent under the hood. And so we have really simple calls to do this. We have CopilotKit customize config, which works with the LangGraph config that every node receives. And there's two types of things we can emit. We can emit the state of tool calls, as we're doing here. For example, the research report is under the hood implemented with a tool call, LLM tool call. So as this is getting figured out by the LM, we are now passing it to the state. And we also have another kind of emissions, which are manual, right? So you can just manually emit state of the agent to the Copilot. And one of the nice things is when the agent finishes running, right? When the node finishes running, rather, all of these things are going to get synced back up. So it's pretty neat. You don't have to do this, but it does significantly improve the experience. So now if we run this one more time, let me refresh this screen and tell it, help me research the life of penguins, use your imagination again, so it cannot spell, pester me too much. So you see, now we're getting Agentic generative UI. We're seeing what the agent is doing as it's doing it. It's updating in real time as it's getting figured out. This is, in this case, just manual code emissions, right? We're doing one sub-search at a time here. It's searching the life cycle, the habitat, behavior, diet, etc. We'll also see that the resources are getting filled out in real time as they come in. So the application state is updating in real time. And we'll also see, yeah, it keeps going, and the research draft will also be updating in real time. So that's really all it took to get this core behavior in here. As you saw, it's like almost no code at all. Those of you guys who've tried to implement something that I'm sure you've seen, takes actually months of work from teams, and they get buried in spaghetti code, and now it becomes very simple. And this is something you heard from top tier teams at top tier companies. One last thing I want to show, actually, before I show this, I just want to briefly speak about also meeting the intermediate agent state. This is actually important for a few reasons, right? So we talked about just the nice user experience. You're not just looking at a blank string or a loading indicator for, a minute. But there's actually deeper purpose as well. With agents today, one of the most important things is building trust with the user that the agent is on the right track. Because everybody has been using these systems and they know that these things work really, really well most of the time. But all of the time, they produce things that look really, really well or really, really good. And so users it's very important to establish trust that the agent is on the right track and searching the right things. Another feature that's going to be coming soon is agent steering using LangGraph's time travel functionalities. So if the agent actually goes off the track, the user can steer it back on the track, whenever they want to. They don't have to wait till the end of a node transition, which is kind of like an arbitrary point that can take, many, many seconds. And so, that's just a few words on this. Lastly, we saw before the human in the loop parts. I just want to show how easy it is to do that as well. You add another hook here, use Copilot action, delete resources, which defines a specific arguments that it takes. In this case, URL is a type string. Everything here, by the way, is typed, even though it doesn't look like it. If you go to args, you see that we get exactly the same types here recurring. And we just return a custom React component based on these arguments. And we get a handler that we can call on people pressing no, we handle a no. On yes, we pass a yes. You pass any data you want here. Usually you want to pass, some JSON object back and forth between the agent application. So yeah, that's the essence of CoAgents. There's a bunch of other features you can look into in our documentation. For example, calling front-end actions in general. It doesn't have to be human in the loop. You can just have interaction between the application and the user. Yeah, that's essentially the essence of it. Let me maybe go quickly into the presentation once again. So just to recap, the high-level features of CoAgents is one, you get shared state between the agent and the application, right? These are no longer two distinct systems. It just takes a few lines of code to do that. If you're curious under the hood how shared state works, you have, the LangGraph agent emits discontinuous state updates across every. Oh, I think you guys might not be seeing what I'm trying to show. Sorry, I had too many screens here open. All right, so shared state. Can you see this near?
I see a screen says shared state
Great.
agent. Yeah.
Great. Yeah, so that's a first feature of CoAgents is shared state between the agent and application, just a few lines of code. These are no longer distinct systems. If you're curious how that works under the hood, LangGraph agents, they emit discontinuous state updates when the agent transitions between nodes. They also emit continuous data streams all the time that you can customize. We bind these together with really simple developer interface into a single continuously updating state object, securely project the parts that are relevant for the front-end application, because some data might be secret or private, and then efficiently transmit this in bits across, so you don't have to kind of redo the whole thing every time. So you only transmit the delta. So that we have shared state. We have Agentic generative UI, which is an addition to the traditional generative UI based on tool calling abstraction. This is based on the agent's current state. And human in the loop, another really important feature. and just real-time front-end action bindings. So you can define any action you want on the front end. You saw it just takes a single hook, very simple, and it's now available to the agent to call on, and all the back and forth is handled as well. And yeah, that's the essence.
Well, it was fascinating. I mean, I'm obviously going to watch this YouTube recording of our session again, just to recap everything you just said. Um, so I have questions of you talked about the future ideas that you have about the agent steering.
Mm-hmm.
Can you share any more ideas that you have about?
Yeah, no, it's definitely. So yeah, I do, having kind of worked with the companies at the forefront building here for the past, year plus, I think I've gotten pretty opinionated about the next 6 months. I don't think I can predict more than that, but I think, yeah, what application is going to look like in the next 6 months is, first of all, just, the Replit AI agent, quote unquote, of essentially every vertical. We saw this with V1 copilots, right? That developer tools were kind of the canaries in the coal mine leading the wavefront. Of course, GitHub Copilot is the most famous one, but at this point, even our terminals developers usually have copilots in them. Um, and we're seeing this again with kind of V2 copilots in these agent native applications with Vercel Replit. They're kind of leading the charge, but everybody else is going to follow. So I think the big question, maybe in the hackathon, people can pursue this. What is the Replit AI agent of every domain, right? What is the Replit AI agent of tax planning software, of insurance software, of whatever it is, of sales, whatever it is that somebody does, and you can actually build things that are useful, not just cool. They're not just look how close it is to something that I pay a person a lot of money to do, but you actually can get a person that already has this job to be 10 times, 20 times more efficient and actually produce something they can ship. So I think that's a very exciting time to be building. And Another kind of opinion thought that I have, which I recently arrived at, that when Chat GPT first came out, there was a lot of question, is chat a temporary interface, or is this kind of like a stopgap until we have something bigger? And to some extent, I think the answer is yes. I think these agent applications synthesize chat um, and applications, right? It's not just a chatbot. It's not just an application. It's a synthesis. But I actually do think that the chat interface is kind of here to stay. And the reason I think this is actually what you and I are doing is chat, essentially,
Yeah.
right? It's a voice and video modality, which is, it's an improvement maybe. So I think that could come in. There's some places it's improvement, some places not. But generally, humans communicate via chat. That's how we communicate. And again, both audio, video, and Slack, text messages. And I think it's just the format of communicating open-ended ideas. So, when you have something that's very constrained and finite, then buttons can work. But when you have something that is open-ended, language is the format, and you really want this virtual colleague that lives inside the application that you can talk to, that works alongside you. And how would you communicate with such a being if not through chat? And I think this is also likely to even remain as kind of the abstractions keep rising up. If you think of CEOs of huge companies, they run their companies with chat essentially, right? They talk to the people below them and they go and implement things. So I think it's a pretty robust, like more robust than we initially gave it credit for, pattern. So that's currently my opinion on this. But we'll see where things go.
Mhm. Now you're speaking about the way that people are going to communicate with the machines. I
Yeah.
wonder how the machines are going to communicate between themselves.
Yes. I mean, I think that there's an interesting synthesis here too, right? Because if you think of this, human loop as ping pong interaction, and you think, okay, we have already this ping pong is very useful, right? You can 10x somebody's productivity, even if you only 10% improve. If you have a large company, like that's a big deal, right? But I think 10x is actually not out of the question. Um, but what you want to automate next is exactly that whatever the human is doing in the ping pong operation. So now you have a lot of data of this ping pong back and forth interactions, and you want to use that to, essentially train the next versions of your models. And training can take all sorts of forms. It can be literally, pre-training, can be, there's a lot of other techniques you can use. So I think that kind of synthesizes, the machines collect the human AI interaction data and then communicate back with the models to build better models. And yeah, so that's but then yeah, I think that's one kind of this machine-machine interaction we'll be seeing.
Well, this conversation that we have now is going to be recorded and kept on YouTube. So in 1, 2, 3 years, we can check what's actually
Can check
happening
out.
and go back.
Yeah. You can see all the things that went totally differently. Maybe we'll be in the AGI world already and live in Jupiter.
Yeah, yeah. So I see here on the comments that people really liked your presentation. Several people said this.
Thank you.
Yeah, and a question for everyone is how can people test, play, use CopilotKit?
Yeah, so just go to our website, CopilotKit.ai, or to our GitHub, and go to our documentation, and there's pretty clear getting started guides all over the place. Again, we have these kind of different parts of the stack there. If you guys are already familiar with LangGraph, I would definitely encourage checking out CoAgents. If not, you can check out, start with the other quick starts and kind of work your way up to the times where you need this level of control. Yeah, that's essentially it. I'm trying to think. So right now the LangGraph support is only for Python, but actually it already is working for LangGraph Cloud and LangGraph JavaScript. So if you guys are interested in this, please reach out. We also have a Discord, so you can find this also on our website. I can also provide you the links near, and you can share them. But yeah, you can join our Discord, ask questions. There's a good community, and we'll also do our best. The team will do our best to help you as well. And yeah, but if anybody's interested in being an early tester for LangGraph JavaScript support and LangGraph Cloud, then yeah, please let me know.
I also heard that you also are going to conduct additional hackathon sometime soon. Is it correct?
That's right. I don't know the dates, but it is true. We actually just had a couple weekends ago Human in the Loop hackathon in San Francisco in conjunction with Google AI as the premium sponsor and AI Tinkers. And yeah, that was very interesting. People built really interesting things. We do want to repeat this. My co-founder will then yell at me later for not giving the dates right now.
Great. So thanks again. I think I personally enjoyed it. I think, and I can see that other people also enjoyed your talk. So, and I hope that everyone that's going to watch this video retrospectively is also going to enjoy it. And yeah, and thanks again for coming and for this speak. And until next time.
Thank you, Nir. Thanks for having me. And good luck to everybody in the hackathon.